students. I am Ekta. Previously, you have learnt about the comparison of rational numbers and basic arithmetic operations on rational numbers. Today, in this part, we are going to see the properties of the rational number. A rational number is a number that can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. You can learn about the general properties of rational numbers like closure, commutative, associative, distributive, identity, inverse, etc. Here, not just the regular properties, we have listed all the properties that we know regarding rational numbers. Closure property, commutative property, associative property, distributive property, identity property, inverse property. After the completion of this lesson, you will be able to know learning objectives to understand the properties of rational numbers, to comprehend and apply fundamental properties of rational numbers. Keywords from this lesson: addition, multiplication, subtraction, division, closure property, commutative property, associative property, identity property, inverse property, and distributive property. Properties of rational numbers. Some properties listed here below will be of good use in solving problems. Number 1. Closure property of rational numbers. Closure property for addition. For any two rational numbers a and b, the sum a plus b is also a rational number. Closure property for multiplication. For any two rational numbers a and b, a product ab is also a rational number. Illustration: take a is equal to 3 by 4 and b is equal to minus 1 by 2. Now, a plus b is equal to 3 by 4 plus minus 1 by 2. Is equal to 3 by 4 plus minus 2 by 4. is equal to 3 minus 2 by 4 is equal to 1 by 4 is in Q. Also, A into B is equal to 3 by 4 into minus 1 by 2 is equal to minus 3 by 8 is in Q. For example, the closure property on integers hold for subtraction and not for division. What about rational numbers? Verify. Solution. Let 0 and 1 by 2 be two rational numbers. 0 minus 1 by 2 is a rational number. The closure property for subtraction holds for a rational numbers. But consider the two rational numbers 5 by 2 and 0. 5 by 2 divided 0 is equal to 5 by 2 into 0 is equal to 5 by 0. Here, denominator is equal to 0 and it is not a rational number. Therefore, the closure property is not true for the division of rational numbers. Number 2. Commutative property of rational numbers. Commutative property for addition. For any two rational numbers A and B, A plus B is equal to B plus A. Commutative property for multiplication. For any two rational numbers A and B, AB is equal to BA. AB means A into B and BA means B into A. Note: commutative property is not applicable for subtraction and division. Illustration. Take A is equal to minus 7 by 8 and B is equal to 3 by 5. Now, A plus B is equal to minus 7 by 8 plus 3 by 5 is equal to minus 7 into 5 plus 3 into 8 by 40 is equal to minus 35 plus 24 by 40. Is equal to minus 11 by 40. Also, B plus A is equal to 3 by 5 into minus 7 by 8. Is equal to 3 into 8 plus 7 into 5 by 40. Is equal to 24 minus 35 by 40. Is equal to minus 11 by 40. Here, we find that A plus B is equal to B plus A and hence addition is commutative. Further, A into B is equal to minus 7 by 8 into 3 by 5. Is equal to minus 7 into 3 by 8 into 5 is equal to minus 21 by 40. Also, b into a is equal to 3 by 5 into minus 7 by 8. Is equal to 3 into minus 7 by 5 into 8. Is equal to minus 21 by 40. Here, we find that a into b is equal to b into a and hence multiplication is commutative. Number 3. Associative property of rational numbers. Associative property for addition. For any three rational numbers a, b and c, a plus b plus c is equal to a plus b plus c. Associative property for multiplication. For any three rational numbers a, b and c, a, b, c is equal to a, b, c. Note, associative property do not for subtraction and division. Illustration. Take rational numbers a, b, c as a is equal to minus 1 by 2, b is equal to 3 by 5 and c is equal to minus 7 by 10. Now, a plus b is equal to minus 1 by 2 plus 3 by 5 is equal to minus 5 by 10 plus 6 by 10. Equivalent rationals with common denominators. A plus b is equal to minus 5 plus 6 by 10 is equal to 1 by 10. A plus b plus c is equal to 1 by 10 plus minus 7 by 10 is equal to 1 minus 7 by 10 is equal to minus 6 by 10 is equal to minus 3 by 5. Also, b plus c is equal to 3 by 5 plus minus 7 by 10. Is equal to 6 by 10 plus minus 7 by 10. Is equal to 6 minus 7 by 10 is equal to minus 1 by 10. A plus b plus c is equal to minus 1 by 2 plus minus 1 by 10 is equal to minus 5 by 10. Plus minus 1 by 10 is equal to minus 5 minus 1 by 10 is equal to minus 6 by 10 is equal to minus 3 by 5. 1 and 2 shows that a plus b plus c is equal to a plus b plus c. Is true for rational numbers. Similarly, A into B is equal to minus 1 by 2 into 3 by 5 is equal to minus 1 into 3 by 2 into 5 is equal to minus 3 by 10. A into B into C is equal to minus 3 by 10 into minus 7 by 10 is equal to minus 3 into minus 7 by 10 into 10 is equal to 21 by 100. B into C is equal to 3 by 5 into minus 7 by 10 is equal to 3 into minus 7 by 5 into 10 is equal to minus 21 by 50. A into B into C is equal to minus 1 by 2 into minus 21 by 50. Is equal to minus 1 into minus 21 by 2 into 50 is equal to 21 by 100. Three and 4 show that A into B into C is equal to A into B into C is true for rational numbers. Thus, the associative property is true for the addition and multiplication of rational numbers. Identity property of rational numbers. Identity property for addition. For any rational number A, there exists a unique rational number 0 such that 0 plus A is equal to A is equal to 0 plus A. Identity property for multiplication. For any rational number A, there exists a unique rational number 1 such that 1 into A is equal to A is equal to A into 1. Illustration. Take A is equal to 3 by minus 7, that is A is equal to minus 3 by 7. Now, minus 3 by 7 plus 0 is equal to minus 3 by 7 is equal to 0 plus minus 3 by 7. Is not it? Hence, 0 is the additive identity for minus 3 by 7. Also, minus 3 by 7 into 1 is equal to 1 into minus 3 by 7. Hence, 1 is the multiplicative identity for minus 3 by 7. Inverse property of rational numbers. Additive inverse property. For any rational number A, there exists a unique rational number minus A, such that A plus minus A is equal to minus A plus A is equal to 0. Here, 0 is the additive identity. Multiplicative inverse property. For any rational number B, there exists a unique rational number 1 by b such that b into 1 by b is equal to 1 by b into b is equal to 1. Here, 1 is the multiplicative identity. Illustration. Take a is equal to minus 11 by 23. Now, minus a is equal to minus 11 by 23 is equal to 11 by 23. So, a plus minus a is equal to minus 11 by 23 plus 11 by 23 is equal to minus 11 plus 11 by 23. So, is equal to 0 by 23 is equal to 0. Also, minus a plus a is equal to 11 by 23 plus minus 11 by 23 is equal to 11 minus 11 by 23. So, is equal to 0 by 23 is equal to 0. Therefore, a plus minus a is equal to a plus a is equal to 0 is true. Also, take b is equal to minus 17 by 29. Now, 1 by b is equal to 29 by minus 17 is equal to minus 29 by 17. b into 1 by b is equal to minus 17 by 29 into minus 29 by 17 is equal to 1. Also, 1 by b into b is equal to minus 29 by 17 into minus 17 by 29 is equal to 1. b into 1 by b is equal to 1 by b into b is equal to 1 is true. Distributive property of rational numbers. Multiplication is distributive over addition for the collection of rational numbers. For any three rational numbers a, b and c, the distributive law is a into b plus c is equal to a into b plus a into c. Illustration. Take rational numbers a, b, c as a is equal to minus 7 by 9, b is equal to 11 by 18, c is equal to minus 14 by 27. Now, b plus c is equal to 11 by 18 plus minus 14 by 27 is equal to 33 by 54 plus minus 28 by 54. Is equal to 33 minus 28 by 54 is equal to 5 by 54. Equivalent rational with common denominators. Therefore, a into b plus c is equal to minus 7 by 9 into 5 by 54 is equal to minus 7 into 5 by 9 into 54 is equal to minus 35 by 486. Also, a into b is equal to minus 7 by 9 into minus 11 by 18 is equal to minus 7 into 11 by 9 into 18 is equal to minus 77 by 9 into 9 into 2. A into c is equal to minus 7 by 9 into minus 14 by 27 is equal to minus 17 into 14 by 9 into 9 into 3 is equal to 98 by 9 into 9 into 3. Therefore, A into B plus A into C is equal to minus 77 by 9 into 9 into 2 plus 98 by 9 into 9 into 3 is equal to minus 77 into 3 plus 98 into 2 by 9 into 9 into 2 into 3. Is equal to minus 231 plus 196 by 486 is equal to minus 35 by 486. Therefore, 1 and 2 show that A into B plus C is equal to A into B plus A into C. Hence, multiplication is distributive over addition for the collection Q of rational numbers. Points to remember. The following table is about the properties of rational numbers Q. Zero and 1 are respectively the additives and the multiplicative identities of rational numbers. The additive inverse for A by B is minus A by B and vice versa. The reciprocal of the multiplicative inverse of a rational number A by B is B by A, since A by B into B by A is equal to 1. Thanks for watching.